How's it going, John? It's great to finally get you on the podcast. I know we've been trying to get this thing going for a while now. It's definitely been in the making for a while, and I very inconveniently had my second kid in the middle of it, so that hasn't helped anything. That's for sure.
Well, thanks a lot, Joe. I appreciate that, and I'm really excited to be here. Timing these kid things out always kind of it's magic. You never really know when they're going to come, but it's important when they do. So I'm glad we could push it around. I'm certainly not as important as that moment for you. So congratulations.
Yeah, thanks. It's it's always like at least with my firstborn and with my second one now, they tell you one date and then it's like 3 weeks earlier, like no matter
Yeah.
what. It's like so this time around with my firstborn, I wasn't ready at all. I didn't have the crib set up, I didn't have anything. And so with this one, I like made it a point, like, okay, this time around, like 2 months ahead, I'm painting the room, I'm getting the crypt done, everything else. So I refuse to be unprepared for this one.
Anyway, early is super early for the first one for that exact reason. You think you got a lot of time. You don't really know how the pressure's going to be. But yeah, I have three kids and they came at all different times. But the first one was actually late for me, which gave me a little more leeway. I actually did a good job of getting the room ready in advance. And the second one doesn't sneak up on you as much. You've been getting any sleep? You look awful awake for someone who's got new kids running around the house.
Yeah, yeah. So I've been sleeping pretty good. It's the wife that does the night shift, and so she's, going from nap to nap, and like when I do a lunch with someone or something, it's always like, all right, let me bring you food, because I know you're you're the one taking the sacrifice
God, she's
here,
doing
you
an
know.
amazing service. That's hard work. So
Yeah,
you got a good partner there. Sounds
yeah.
great.
Luckily, she's a teacher too, right? So, she takes her maternity leave right when the kid's born, obviously, or a little bit before, and she gets it all the way through the rest of the school year, and then she goes into summer break. So it's like, man, you're getting like 6 months, 6 months
Super.
off from work. Not like you're not doing anything, but still, it's pretty awesome.
She's definitely got a job, but on her hands doing the raising the kids. But that's really lucky, right? That's a luxury. You get to spend some quality time with your newborn, and I can't think of anything better to do, really, if you put it in the grand scheme of things.
Yeah. Yeah. I started my career, obviously, like probably everyone, going into the office, like everyone else, right? Every single
Yeah.
day, 5 days a week, going into the office. And now that I work from home and I've worked from home since, 2020, like everyone else, basically, I just couldn't imagine going back into the office and how much I would miss, with my kids and everything. I mean, I'm there when my kids wake up. I'm there when they come home from school. I'm there in between, like
So good,
it's
so
like,
good.
yeah,
Yeah,
it's so
what a
hard to
great
put a
time to
number on
be.
that.
No, there is no number. It's the most precious time ever, and the fact that you get to do that and do your job and do your podcast and all these things is like a luxury, awesome thing. I had my kids a while ago, and it was go to the office every day. And I was lucky enough to have a wife who really managed doing a great job with them and keeping the family on track with all the things. And I wish it was different. I missed some good time with them and spent a lot of time with them, coached all the sports and things like that. So it paid off in the end. But yeah, it's cool to hear that you're enjoying this time in your life.
Yeah. Yeah, I always really do my best to like enjoy the present and plan for the future, So like that's kind of how I approach, just about everything, right? Is
Amazing Zen. Perfect tip for the audience.
yeah,
That's how we all should live. Very cool.
yeah, yeah, awesome. Yeah, John, I started this podcast, give you a short background, right? I started this podcast because I wanted to talk to experts and hear how they got into the field because I remember when I was trying to get into cybersecurity, I had the worst time trying to get into it and no one would give me guidance. No one really took the time of day to like tell me like, hey, these are the top 5 things that you need to really work on. Like even when I would get rejected by employers, the only feedback I'm getting is, oh, you don't have Splunk experience. Well, thank you, because that costs 200K a year for me to run, in my home network or my company network. Yeah, I'm not going to be able to get that. So I always start everyone off with telling how they got started. because everyone's background is unique, everyone's journey is unique. And I think that it's valuable. It definitely would have been valuable for me back then to hear someone else's story that I maybe related to. Maybe I said, "Oh, that sounds like me. That sounds like what I'm going through." And
Right.
just given that little, motivation to hear, "Hey, if John can go through it and be successful, maybe I can go through it too."
That's yeah, it's my journey's kind of interesting. I think, build cybersecurity companies. That's like what I've been doing for the last 20 years. So we start, and that's a lot about imagining a better future for, you know, very important cybersecurity use cases. Like the one I'm currently working on is how do I help organizations remediate vulnerabilities faster in containerized workloads? Like faster, better, more efficient, less work and energy expense in the company. That's what I'm currently working on. Now, the journey to from sort of, I've been around a while, I've been in the industry like 25 plus years, right? The journey for me is an interesting one in that I've always been sort of a builder. I was working in startup companies and my own companies since like 24 years old, right? So like very early on, I had this entrepreneurial bent and I always kind of took my own path to thing. And I think there's a parallel we can help your listeners take along with them, especially in this day and age. So it's a very simple, like I'll super summarize this. One of the early companies I founded was an internet service provider. Like literally, I had an ISP that I founded that had dial-up modems. That's how long I've been around, right? Like dial-up modems. There was no cable internet access. There was no big Verizon network doing this stuff. It was mom and pops with a T1 doing like internet access for the neighborhood and the people around you, right? And so we had to deal with like early stage network security stuff that like there was just not a lot of information about doing. So we genned up firewalls on servers and did all kinds of things. And then Checkpoint came out with their firewalls. So I kind of got pulled into being like, I'll call it a specialty. Like myself and my founders were networking guys. I was also building other networking products at a different company that I had founded. But basically, I had to do security well to do my day job well, which was build a product that was network service provision. So I had to learn a lot about network security. I had to learn a lot about securing the infrastructure that we were building. So pretty straightforward stuff. Now, fast forward, that was a networking company. And slowly but surely, my career kind of transformed into being from, I'll call it hardware networking and building hardware systems to building software systems. And along that journey, we built a software company at that time. We got a malware attack that kind of did damage. And we were building software for other purposes. It was software towards networking, but it was like the first time I'd encountered a meaningful attack on me that the root of it was software security. Like I couldn't get through that malware attack. And so I really took it on as like a pet interest. I said, you know what? That's never happened to me again. This is my new passion. And I literally at that moment flipped the corner and said, I'm only going to work on security problems right now. And I need to stop this. This is terrible. It revealed itself to me as wow, this is a really dangerous thing for anyone, especially organizations that can be subject to this. The internet was a thing now, right? And it was easy to mess up. And I thought, wow, I have some purpose in this. I really feel like I can make a difference. And since then, I really not started thinking about anything other than, I not stopped thinking about software security, web application security, SaaS security, you name it. And it sort of led me down a really fun, interesting, and great career path where I've built now several big businesses and companies, both starting them from small and growing them to raising venture capital and building companies like I'm doing now to running a $500 million cybersecurity business in Cisco. And I would say the takeaway for that, like let's bring this down to ground, right? Like, so that sounds like a lot of stuff happening fast. It wasn't. Really invested in learning. I studied everything I could. By that time, the internet had volumes of information. I read a lot of books, like how to hack. I wanted to think like a hacker. I wanted to act like a hacker. So I'm an engineer, right? I'm a curious engineer with good programming skills, with good hardware engineering skills. I know how networks work. I know how software works. I have background in engineering degrees and stuff like that. So I um I really made it my pet passion and then turned it into my business passion and business focus. And it started with the pet passion, which was, hey, can I learn how malware works? Can I investigate that and try it myself? And I'm telling you, if I had AI on my desktop to work with back then, it could have accelerated my learning a ton. So I would say, like, for anyone who wants to get into it, be curious, find something that you're passionate about, put in the work and effort to learn it really well, and make it so that you can demonstrate that learning. And I think in today's world, that's, like, make a GitHub repo of your examples, like build something that actually demonstrates your knowledge or demonstrates the problem, or, and again, you're a guy who does blogs to help people learn, like, put it out there, put it on your LinkedIn, put it, like, learn in the open, and really get people to recognize that your passion's there and that you're putting in the energy. And I'll tell you, in cybersecurity, you got someone who proves they know something, shows they want to work hard, can demonstrate their value. There's like a million jobs so in cybersecurity that are unfilled around the world. I mean, like, I think you can actually build it yourself by rolling
Yeah.
up your sleeves. And that's pretty much my journey.
This episode is sponsored by Root.io, a leading platform for container security. They've supported our podcast, but I want to be clear. Root.io did not influence or direct any specific questions or content in this episode. All opinions and discussions are my own.
And it's taken me a long way. It's really, really fun.
Yeah, that's it's a fascinating journey because I feel like everyone knows what to do, right, or how to do it to be successful, but not a lot of people go down that road, right?
Right, right,
You said you kind of mentioned that you're like a lifelong learner. You really dove into this thing, head first. And I really relate to that for sure. Like security isn't just something that I do 9 to 5, right? In case people didn't realize, like the podcast hints it a little bit. But, I'm also challenging myself significantly in other ways, right? So I'm getting my PhD in securing satellites with zero trust to prepare them for quantum encryption, right? Like that, all three, all two areas of that category, right? Zero trust, I know,
right.
right?
Yeah, yeah, yeah,
That's
that's
the only
right.
thing I'm bringing to the table. I know zero trust, but satellites, never touched them, never looked at them, never researched them. Quantum, I didn't even want to look at it. I mean, even to this day, like, I finished, I think, like my 50-ish page section of my dissertation on quantum. Just giving a base foundation, doing my best to not sound dumb while
Yeah.
talking about quantum, right? I just finished it, so I'm not even trying to think about it now for the rest of the year. But doing those
Congratulations,
things,
by the way. That's huge. Huge. That's a huge part of the lift on getting to that point in your education, right? The
yeah,
dissertation and
yeah, my research plan actually just got approved, I think like maybe last week. And I was torn with emotion because I was like, man, I kind of hope that they would have like denied me and said, no, this will never work. Just leave the program.
right.
But unfortunately, they approved it, and so now, I told my chair, I was like, it looks like I actually have to do this stuff now.
Congratulations. I hope that I'll be calling you Dr. South here next time we do a podcast together. That'd be super fun.
I'm sure we'll do one more before I actually get that accolade. But
Okay, cool.
but you know, I take those two experiences, right, that you had and that I kind of outlined quickly there. And I think of a few friends of mine that didn't put that time in and now they're unemployed. And now they're in a situation where they're looking like, the other million, 2 million candidates out there for these jobs when companies really want someone that is passionate about it, and it's doing the little things that show that interest, that show that knowledge and that passion outside of your 9 to 5. Like you said, a GitHub project speaks volumes. It speaks
That's right.
so many more volumes than an interview ever will.
And it's also an open book on your work that people can look at and collaborate with you on, and even see into your soul, so to speak, on how you think and what you do. And that's like the best living example of your work, right? I'll mention one other thing. I was lucky to get mentors early in my career, like people that invested, like, believed in me and invested time in me. to help me, whether it was a person at my company that I had been working for, or like my partners in building companies, or we got acquired several times. I've had 5 of my companies acquired. So like one of the early ones, I was still a young guy. I was like not even 30 yet, and we got acquired. And like the that and I saw it happening in this organization a lot, where younger people with ambition would easily garner the attention of someone with experience, and they would take them under their wing. And I had the luck of having that several times through my career, through these acquisitions, or even through customers and partners. I'll say that you know, people are generous, right? Like on average, I think when people reach out to me, I've had this happen lots of times, several times, where somebody will LinkedIn me, a person that's just out of college, and ask me questions about my career, what I'm doing, or say, "Hey, John, I'd love to talk to you for 15 minutes to talk, see, like I want to go down this path. Can you talk?" And I do it, like I do it. I mean, not as much as I'd love to do it, but I when it comes up, I'm like, that's a chance to give back. And I think if you ask people to help you out, they do. And so I think that's another lesson for people like who might be trying to go down the security career. It's like, go to a security meetup in your area and just talk to people, ask them what they do, be curious, put yourself out there, say, "Hey, I want to get into security. Like, can you give me some advice?" And I bet that pays off hugely, because join the Cloud Native Compute, forum, join OWASP, and it's like $50, right? Join OWASP, be curious, show up to the meetup in your town. Chicago's got a great like OWASP community, right? And go be around security people. They'll guide you. Uh, Contribute to an OWASP project. It's out there to do. Like I know, for instance, Steve Springett, like a close colleague, he runs Open OWASP dependency track. It's got like 1,800 different organizations that use it like a mainstream product. He's in Chicagoland. That's where he lives. Go to the OWASP meetup, talk to Steve, go show that you know something about dependency track. And I bet you one of those 1,800 companies would love to know your name. Simple stuff like that.
Yeah. Yeah, that is actually really true. Putting yourself out there is probably 90% of the battle, right? Like I remember when I was getting started, I would go to those meetings
Yeah,
just to meet people, learn something, and I would bring a stack of resumes with me and I'd hand them out, like
there you go.
what do I have to lose? Someone going to
I
turn me
went
down?
exactly right. I went to one of those in New York City probably 6 months ago, and half the audience were college kids from one of the universities in New York. They were all graduating in the cybersecurity program from that university, and they were out there talking to like grizzled old professionals like me and all the guys there. But they've linked in with me now. They send me notes. I have you meet someone and you get a little like investment in their name and what they do, and you're like, I saw that guy at the thing. Yeah, you remember it. And that little bit of ingenuity, it goes a long way. It makes the people take notice. I think
Yeah,
it's beautiful.
yeah, yeah. It's interesting also leveraging, your network, right? Like building that relationship, really, really diving into that. I take a lot of pride when make a recommendation, to someone for another person that they've never met, and I give that recommendation and, the person I'm giving it to says, automatically it's a yes because Joe recommended him, right? Like that really, I feel like that speaks volumes, to my own reputation within the industry where it's like, when I say something, I really do mean it. I'm not just saying it just to say it, right? And I personally take a lot of pride in that. I like helping out people and I always try to go out of my way and do it.
I think that's a pay it forward moment, right? Like
Yeah.
especially if you're invested in the industry and the cause. I don't take cybersecurity as just like a day job. I really want to make a meaningful impact on the future of cyber safety for, my family, my kids, the future, like it's really good work. Like, holistically and in the big picture, we're doing work that like literally helps the masses, saves a ton of money, and really is a battle, of good and evil. And I hate to be too trite with that, but it is really that, right? And so, you know, paying it forward so that you help the next generation of people coming in the industry to drive the good guys forward is good work. So something to be proud of. I think I hope helping people out in this field is
Yeah, absolutely. Well, John, talk to me about the problem that, you identified that led you on the path to creating Root.io and the solution and the product behind it.
yeah. It was a very practical and close to my heart problem. So as I've mentioned, I've aside from starting startups with like four guys and an idea, which we did with Root, I've also run some pretty big businesses inside of Cisco and inside of CloudLock and others, like you know very large businesses with very big um, infrastructure and cloud native applications running in AWS and in custom infrastructure, et cetera. We've been building containerized software for a long time. Since the dawn of containers and Kubernetes, we've been building on that and building that really, like, for instance, applications that were in the product area that I ran at Cisco had, like millions of users and hundreds of thousands of companies using it. The Cisco umbrella was one of the products, and it was a really popular product. Security is paramount there, right? Like, I take seriously like the products I build for the value they create, but I also take seriously the fact that that's a security product. It needs to be really friggin' secure, right? Like super secure. So it's always been near and dear to my heart to like do a great job with the AppSec for these applications we build. And one of the challenges I had at Cisco and at other companies we've been building cloud native workloads is how hard it is for organizations to get a handle on the software supply chain security and the vulnerability management for these applications. So specifically what Root does is it helps organizations remediate vulnerabilities and lower the attack surface on containerized workloads. So, your container image is the embodiment of your software supply chain. Like, it is the running implementation of the software you build and the software you use. So if you look at any container image, it's like 95% open source software, Linux, Python libraries, etc. Like, the world of open source provides, and it provides all that free software, free as in speech, not beer. It's not free. You still have to pay to use it effectively. Like, it costs you, to secure it, but it didn't cost you a license fee, and it's your, to freely use. I always say that, software is more like free puppies. You get them and then you got to do a lot of work to make the puppies successful, so to speak. But anyway, that challenge of putting, I'll call it vulnerability free and low risk profile containers into production was really hard for these companies to do. And it puzzled me. I'm like, well, what? 1,000 engineers. We had like, a massive organization, and we were going through things like FedRAMP compliance, and we were doing a lot of like really strict security management on these things. And I'm like, why, with all the resources we have at Cisco and all the know-how and the great engineers we have, why is this so hard to do? We get our vulnerability scanners scanning these containers. We get these long lists of vulnerabilities. And then we'd go, okay, let's try to get a handle on how to fix these. None of the tools could remediate. So first of all, the biggest problem, like problem number one, a lot of scanners tell you about vulnerabilities and none of them do anything to fix it,
Yeah.
basically. And I think that's largely still the case today. And then changing out the operating system or moving to a new version of the operating system. Operating systems are where most of the vulnerabilities come from, by the way. It's probably some in the know, but it's like the base image typically has like 80% of the vulnerabilities in it. It's getting to be the point where libraries also have lots and lots of vulnerabilities, but you can get a lot of bang for the buck if you just fix up like the Debian layer in the container or the Debian layer plus the app foundation layer. I saw our engineers struggle mightily to get any progress in that. Like, why can't you change the OS? Well, if we do that, this dependency will break, or it's going to take us, we can't build the next three features and that you want to deliver in 6 months to get our customers happy. If I do that job. So which one do you want me to do? Do you want me to make the software secure, or do you want me to ship the features? There's always this. And then of course you got sec engineers, like, people that I like, like I revere, are like saying, you got to fix this stuff, man. I'm not going to be able to do the FedRAMP. The federal, like all these pressures from compliance and security governance, which is like good, means that you're building secure stuff, was at odds with my roadmap. And then when you get the engineers to work on this stuff, they don't like the work. They'd rather make features, not fix debt. And this is
Yeah.
security debt, right? So it's like, they don't want to work on fixing these things. And so I searched around for a lot of solutions. There was nothing. And we started this like 4 or 5 years ago. And what I realized was, look, if I'm going to I kind of went on like first principles approach to this. Me and my co-founders were like, what would be the most beautiful experience that you could ever have that would be cost effective, it would solve the solution fast, meaning like organizations wouldn't have to have some heavy lift. They could work in the same workflows that they have now, meaning like they didn't have to change their build tools, or they didn't have to switch operating systems like from Debian to Alpine, or they didn't have to like do a heavy lift. And I didn't put a bunch of shift left work on the plates of developers. So they know they don't like to do it, right? They don't want to fix that shit. They want to build new shit, right? So I'm like, what is the perfect solution? What would really move the needle and make it easy for organizations like mine to have this like low effort, high efficacy security for container images, get to zero vulnerabilities, but not to create a new pile of work to get that job done. And so Root AVR was born, this product we have. And at the core of it, it gets to the heart of the matter very quickly. What we do is we patch container images. We patch them so they get to zero vulnerabilities. And we do it fast. Fast forward to now, we came up with that like Nirvana solution that I wish I had when I was working at Cisco. Took a while to figure out, worked really hard, got a bunch of smart people together. Me and my co-founders have been passionate for this thing. But in the end, we achieved that, what I said, which is, can I build a solution that can take any container image that we have and convert it into, patch it into a zero vulnerability image in 5 minutes, in less than 5 minutes. And that's what our product does. It makes container images go to zero vulns.
So, okay, that's really fascinating to me, right? Because I'm someone that, has been on the security side that was over there buying developers and engineers drinks and
Yeah,
lunch just to get them to
I know it very well.
kind of do like their part of the job that I really need them to do desperately, right? It's like, hey, yes, I can technically do this. Like, I know how to do it, and I probably even have the access, but please, can you just do this for me? Like, put that feature on hold for one sprint. So, talk to me about how that's accomplished, right? So, from what I understand from container images, is essentially, a file, right? And then you're probably, and correct me if I'm wrong, you're probably updating the different components of that file. And then when the container, because containers are supposed to be short lived, when it, you know, goes down and then it starts back up, it's using that new patched image and it kind of just rolls through the environment like that.
That's generally right. I'll dig in a little bit more. I'll go like a layer below that. That's like directionally very right on. Again, I mentioned that at the heart of our solution is this ability to patch images. And we do that on an image, and it's your image. So at its edges, our systems kind of schematically, it works at a high level like this. You attach it's a SaaS service, so it's a patching service. You attach us to your registry where you keep your images. And typically we start by operating on an organization's base images. Think of like Node on Debian or or Node on Alpine or PHP on Debian or Elasticsearch on Debian. Like you have these kind of app foundation images where you have like a Node or Python environment, or you have like, I'll call them infrastructure applications like Redis, Postgres. These are the kinds of images I'm talking about that you start with. And that cleans up, by the way, when you get these to be clean, that takes a ton of vulnerabilities out of the environments because these images get propagated over and over again, right? You build as a company, you build your images on these foundational images, and then and you derive a lot of your microservices from the same base images if you're doing your DevOps homework, right? So we focus on those, I'll call them foundational image sets. They're the 10 or 15 or 20 core images you use to build your SaaS from and you derive from. As you know, with images, you can, in Docker files and other means, you can derive from, so you can do like a multi-stage build. The first thing is you build your base, and then you add more layers to it as it goes. And that's kind of a pragmatic way to organize around these base images. So we plug into your registry. So you just put a registry integration into our system. You can tie us into your CI/CD pipeline, so you can trigger us to run whenever you want us to create a new base image for you, or I'll call it AVR your base image, patch your base image. These base images often come from places like Docker Hub, or it's something somebody generated that first Docker file for, but a lot of times they come from community sources or public sources, and then they get modified. But we start with those images. And then if you want us to act on it, you just tell us to go and act on the image by triggering us with your CI/CD pipeline or through our UI. I'm happy to do a demo later on in this session to show you exactly what it looks like. But once we run, we literally pull the image into our system, into our SaaS. We open it up. We analyze its components. I'll say largely we use a simplistic model, but containers are layered. They have something called a layered file system, right? And the base image lives in whatever layer was specified, and so on. You build up. And some containers I've seen that have as many as like 100 layers, but on average they
Jeez.
have like 4 or 5, 6, 8, something like that. Small number of single digits number of layers. So in a simplistic model, most containers that go to production have like a 4 macro sets of stack. It's like the operating system or the very base layer. It would be like Debian Bookworm, right? And then you have another layer, I'll call it macro layer. It could be multiple container layers, but the next thing is like application foundations or applications. So that's where Redis would fit into the container stack, or Python, the app foundation, the library Python, right? Like Python you might install on your computer with its basic packages. Layer 3 of that stack would be like the Python libraries I need for my requirements.txt to actually build the application that I'm trying to build. And the fourth is called first party code. It's code you write that uses all that stuff, just like you do it on a computer, but in a container. We worry about third party code, those first 3 layers of that stack, making that secure and patching that. And that's, as you mentioned, we apply patches. So we apply 2 different kinds of patches. Our system can automatically apply patches to those first 3 layers by simply doing upgrades. And we have a patch planner that knows how to do that in a way that's very low likelihood of breaking your application. We look at the composition of the container, and we choose upgrades that are safe. That's kind of a cool tech that we've created that kind of does some estimation on that. And then even if you do a perfect job at that, there's going to be lots of vulnerabilities left over because many vulnerabilities don't have patches in the ecosystem. Debian is notorious for this. About 70% of all the containers in the world are based on Debian that run in cloud native environments. There's a large number of vulnerabilities that are critical and high that Debian does not have patches for, because they've decided to defer patching those to future versions of their operating system. And they kind of leave it up to the community to figure out, but no one does. So the other part that we do is we go make patches where they don't exist in the world. And we have a very big library of patches we've developed you can't find anywhere else.
Really? Wow.
We've built an agentic AI system that augments our research team, and it does this extremely efficiently and extremely accurately. We've invested a lot in automation and a lot in agent technology over the last year and a half to make use of the cutting edge of AI tech to do this. It's a really complicated thing, meaning like making these patches requires, well, we patch times hundreds of libraries, and it would be like nearly impossible for engineers to understand all of those. Like we literally have to understand all the source code in those libraries. Like it's hundreds of open source libraries to patch. Expert knowledge required. We have a great research team of expert patchers, guys who know how to do this work really well, and they like doing it. The first thing is nobody likes to do this work. I got guys who like to do this work. Um, and we've made agents that love to do this work. And it turns out that agentic AI is really good at this problem. For instance, Claude, Anthropic's agent, they've spent a lot of investment in making Claude a really good coder. And it turns out this is one of those coding problems that we figured out how to make these AI tools be really, really good at. Now, obviously, we know how to do it and we're really good at it. And we have lots of examples and we have lots of training data and we have lots of things. But at the core of our system is this ability to create patches where none exist, and then patch in a way that doesn't break things, be really surgical with all the upgrades and patches. And then third, our system automatically applies them to the container image by creating a new container layer where all the patches go. We then build, once we figure all that out, we get all those patches there, we then build a new image and then push it back to your registry, and we just tag it with _root.io. And the culmination on an average, like say, I can show you later a Python image that we do this for. The amount of hours, it's dozens and dozens. If you could even figure it out, like we can patch an image in 3 minutes that would take any team, like literally any team, with any other competitive solution or approach, days, maybe weeks. And our system can do it in like, well, I'll show you while we're on this call. Now, that's the culmination of a lot of really cool research and work and engineering and building this massive software factory in the back end of our system. We've got a SaaS platform that makes it really easy to interact with and connect to your world. Everything's got APIs, but that's pretty much the high level thing. Container in, analyze, plan, apply patches to wherever we need them, reconstruct the container, emit the container, and you're done. It happens in about 3 minutes. For the average container size, your mileage may vary depending upon the size of the container. Now, the other thing I should mention is that as soon as we see your image, and that's your image, by the way, I didn't make you change over to my image. That's your image. Whatever image you chose to direct us to try this on. Competitive solutions, most of them are image libraries. They sell you a bunch of images. They're super expensive. The way they deliver them is super expensive for them to do. That's why they pass those costs on to you. And it requires you to rebase your images. So to start with those solutions, you got to go back to your engineering team and go, hey, listen, I got a great solution. Everything's going to be great. All you need to do is re-engineer all the images we have to use this new operating system. It's going to break everything in the beginning, but that's okay, because as soon as we get over that massive toothache, things are going to be good. But they actually don't turn out good because many applications can't port. Like if you're on Debian or Ubuntu, you try to go to Alpine, stuff just breaks. And you've got this massive lift. It takes you months to get started with those solutions. This was also one of my goals. I want anybody to be able to start in 5 minutes. And with our solution, there's none of that. You start with your images, with the stack and applications that you love and already know. Your engineers are all tooled up on it. You have all your DevOps scripts and languages and all the things lined up. Your CI/CD pipeline understands everything that's going on. Your scanners understand everything. We start with that image. We patch it to 0. You have your image, but better in 5 minutes. And so, we checked all the boxes on our wish list of how we could make this good for John Amaral, 4 years ago at Cisco. And here we are doing that. Now, as soon as we see your image, if any new vulnerabilities come up, because we know your image, we go patch it. We find as soon as a new vuln comes, our software factory and our AI agents kick off a process where they go figure out what to do automatically. So you've been in security a long time. Patching SLAs, right, are pretty strict. Depends on the regime, but with FedRAMP, it's 7 days for a critical. What do you do when no patch exists? Well, you're kind of you got to do a POAM. You're going to be on the hook to for Kanban, right?
Right.
Etc. Our autonomous software factory has always got your back. So it's it's like you take the engineers out to lunch, you try to get them to pay attention to the security stuff you want done. Our system doesn't need lunch. It just needs electricity, and it wants to solve all your patches for you. You don't even have to take it out to lunch. So that's how it works. Questions, comments, thoughts? I'd love to hear your take on all that.
I mean, I think it's really, really fascinating. You're kind of teasing me here. Now I want to dive into the tool.
Let's go. Let's go. I'm going to do a screen share. Good thing we tested this early. I know it's going to work, so that's cool. I'm just going to press go on the screen share and.
Yeah, when you said screen share earlier, I was like, we need to test that because I've never done that before on this.
All right, we're forging new ground on the on this podcast. I'm gonna do this guy right here. Nope, that's not the one. That one. There we go. Share. Hopefully it works twice.
There we
Are
go.
you seeing my screen?
Yep.
Cool. And hopefully it's zoomed in enough so the audience can take a look. All right, so I'll get in and certainly stop me, Joe. And I don't have. This is covering your face now, so I wish it wasn't that way, but it is. So just yell at me to stop so you can ask questions as we go. So basically, there's a bunch of parts to this solution. One is we've got this dashboard that's trying to give you a high level view of all the good work that this solution does for you. You can see, and this is just a test account. I test all kinds of containers in here, but in the profile of containers I've done, you see that I've had a 73% vulnerability reduction across all issues. It saved 77 days worth of work, 270 vulnerabilities are remediated. I sometimes throw stuff at this that, are really hard tests for it, but in general, it works very well. at remediating, and you have an easy way to see what's going on. The system really, kind of runs from this point. This is the remediation tab. This is where you get started. It allows you to connect a bunch of registries. So we have pretty much every registry under the sun, as I said earlier. First thing you do is you tie us to your registry if you want us to work on your private images. We also work on public images. You can start by picking something on Docker Hub. That's what I'll do for this. But when you connect this up, you just put a registry token here, a security token. And then once we have read-write access to that registry, when we remediate an image, we just push an image right back to that same registry, but tagged with root IO under it. For public images, this is like a super simple way to test, and anyone can sign up and use this platform. There's no gating on it. You can go check it out yourself. You can do all the things I'm showing you here without any intervention from our company. We don't ask you to call us for a demo. You just sign up, try it, and it's easy. I'm going to pick Python. I talked about that earlier. You just select one of these images, or you can pick from whatever tag you want up on Docker Hub. Today we support, as I mentioned, Debian, Ubuntu, and Alpine images on AMD 64. Pretty wide support setup. And then you just click the remediate button. It's going to bring up a modal dialog here that kind of tells you what's happening. So you first pull the image, you scan it. We have the Trivy scanner under the hood. We also create an SBOM of that image. Once we do that, we go into this like evaluation mode. We look at the container composition, the packages, the vulnerabilities, and we make that patching plan I talked about, where we do patch selection from the upgrade list, try to select patches that have a low semantic version difference from the package that's in your image. But our goal here is to kind of like preserve the 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 packages you have from a major and minor version perspective, and bring, I'll call it, very small change upgrades to it, just targeting those vulnerabilities. Now, the goal of this is not to upgrade functionality. It's literally to patch away the vulnerability. So we're very targeted in that. And of course, we also select from those root patches that we've generated that we can use with the same mindset. It's like bringing these patches to bear to literally target elimination of vulnerabilities, so that your risk profile in the container and your ability to meet compliance for vulnerability counts and SLAs is made easy.
Yeah, it's fascinating because I'm wondering how long it took you to like train the AI model to build up to the point where it kind of knew what to do, right? Where it was becoming more effective for your use cases. Can you talk a little bit about that potentially?
We're pushing to roots registry. That's what it should do for a public image. So now it's
Hmm.
scanning. So let me take off from here, and then I'll answer your question in a minute.
Okay.
So it's scanning the image now. It pushed it to an internal registry that we have, ECR registry, where we create a temporary location for it. This is the public image, so didn't have your registry to push back to. We scan it again after we do all the patching, and then we then present the findings and a link for you to be able to go and retrieve the image. So part of this is we generate VEX and SBOMs for everything we do. So the VEX statements actually have a very detailed record of everything we patched, all the new packages we applied, and you can use that VEX file to inform your scanners of these package changes, because natively most scanners don't understand these package changes because we've generated them. So we make it really easy and transparent for users of our system to be able to do that. And voila, here you go. We've got an image that had one high and critical, and I'll show you more about this in a second, down to 0 highs and criticals. Now, that image was a curated image that already had like a bit of it risk surface reduced. And then here is a full command for Docker that you can go and grab that image yourself, drill in and get the full report. And further, it just didn't get rid of the high and critical. It got rid of all the mediums. So this container has 0 highs, criticals, and mediums. This is a very typical result for the image, for these operating system images that I've shared. It could be Python, Node, whatever, PHP, but we have very good success across a whole bunch of images. I'll show you the kinds of images we operate on, and because we have a big list of those that we test on and offer as, I'll call it, convenience images for people. But we don't sell images. We sell this service. You can run this on your images. If you have a Python version that's on Debian that you use for your base, or Node, or you name it, you don't have to rebase. You just run our tool and you get a new image that has much less vulnerabilities. Behind the scenes here, we added 18 of these root patches, these custom patches that we developed using our agentic AI system and our really fabulous research team. And something to note, I mentioned that these semantic versions are very close. So, in fact, this libcap2 vulnerability has no patch in Debian. That's why it's a root patch. And we actually provided a patch for the exact library you had with our root extension, and we probably only changed a few files and like in a kind of a small number of lines of code, probably less than 100 lines of code is typical that we'd have to change. It's very surgical. It doesn't change anything with the package that would make it any compatibility issue. All of the capabilities, file signatures, we regression test these libraries so we know they work exactly like the version did prior to patching. So it's an exact fit, except the vulnerability has been patched away. And that's what we do. We work
So,
on the who's who of images. Just one more thing, sorry. You can come in and look at our image catalog. These are all images that we have done extensive testing with to show that our AVR works well across those operating systems. In fact, these images are also, they're not patched by us, but they are, we do offer these as images that we've curated a bit because I think if you just go download these from like, public registries, they'll have like, some of them have hundreds of vulnerabilities. We've done a service to the world to make these like, something much smaller and much more, I think, lower vulnerabilities, because I don't think you should start with that 500 vulns. But then you can run these and patch them down to near zero or zero with our system. So if people want to use these, they can, but it's not necessary. You can just use what you got and run it through our system, and that's how people do it.
so with the patches, that you showed on the previous screen, it, are you essentially, is that considered backporting a patch into
That's
the
exactly right.
package? Okay.
Exactly right.
Yeah.
That's a backported patch. And our agentic AI system and our researchers, what they do is, for instance, for that one I showed you, libcap, and this is true for every one of those patches. Our research, we have two agents. We have a research agent and a patching agent. The research agent goes out and researches the vulnerability, and it researches the effectively it scours the internet. It knows, good starting points to look, but it goes and looks for code commits to either the it goes and looks at code commits to this ecosystem of libcap. So it could look at the maintainer's GitHub repo where all source of code comes from, or it could go look in Debian's repos. You name it. It could look in Ubuntu's repos. It could look in, we look for places where we find a fix in a later version of that library, or we look for a fix that may exist that's never been merged with that library. And these happen in two forms. And then backporting happens when we find those, and then we basically analyze our patching agent. Once the analysis is done by the research agent, the patching agent takes that research and it does code analysis on place where that fix exists, maybe a newer version of the software. Say libcap was version 1.3.5. If 1.2 has it fixed, but 1.35 doesn't, we look at 1.2's code. We have our patching agent examine it, understand the changes that were made related to the commits around that fix. We deduce all of that. We then look at the code in 1.3.5, and we fit those changes into that code base. Build a set of commits for that, merge it in, and then run extensive tests on that library to make sure that we didn't break anything, and also verify that the patch worked, meaning that it actually did mitigate the vulnerability. So there's a lot of testing, and there's a lot of this backporting and code. I'll call it code identification. But that's
So,
exactly how it works.
is there, I mean, maybe I'm just not as familiar with like container security patching overall, right? Is there a possibility of running into or inducing issues with this kind of style of patching and maintaining those images? I ask kind of twofold, right? If something does go wrong, how do you go backwards? And two, is it even like reasonable to think that things would go wrong, which sounds very weird from a security perspective, right? Because in security, you're always assuming something's going to go wrong, something's going to break, there's going to be some sort of issue, right? So you always have to have like that backup plan in your back pocket just in case.
Yeah. So that's a good question, a good multi-part question. I'll unpack it. So first of all, as I mentioned, we're extremely surgical with these changes. This kind of patching is not, I'll call it exotic or foreign. This is what you do when you need to patch stuff. Like we're simply using upgrade mechanisms that are built into package managers, et cetera. The sophistication here is figuring out which patches to apply and also building patches. It's not uncommon. I think maybe that's an understatement. It's common um, and universal that folks pick up new container images when they want to have upgraded packages. I mean, if you got your image off Docker, how do you wait for the next version? You got your patches there, you take them, right? Or you run APK upgrade, or you run the upgrade on the Docker file. You build a new image, and that's your new image. So it's not uncommon to upgrade these things. This is all third-party code, so you know it's very unlikely. It's mostly never the case that people have these libraries as something they build. Like when you use Debian, you don't start with Debian's source code. You start with Debian's images, or you start with Debian's distribution, right? So patching this way in containers is not foreign at all. It's actually quite natural. It's normal. As for breaking, that's the we don't break images basically because we really manage the change scope, and that's the key. That's the like art of this. Backported patches have really high reliability, um, and these semantic version differences, like these are just the only code that changes is just the code that's needed to fix that patch. And when we select upgrades, we also look for really small semantic version differences. And that means that these are just security updates, which are, technically with a good provider, that semantic version difference means that they've only introduced security fixes. And and the implicit guarantee is that those don't have any like functional breaking changes. Now we do a lot of verification on this stuff to help make sure that that's the case, but in general, that's a good assumption. So we're doing kind of normal things, we're doing them very safely, and we're really good at doing it well. Now, how do you go back if something breaks? Well, you have the original image. We only patched the one you gave us, right? So you've got our image, you got your old image. Now, if you got DevOps maturity and you run tests and staging and all that, you put our image into your normal DevOps flow. So you just run us through your normal testing paces, and away you go. So again, I mentioned that we put all these fixes in one layer in your container. So literally like layers 1 through N are your layers, untouched by us. Layer N+1 is our stuff. So everything's isolated there. The cool thing about the layered file system in images and the way they build is you can kind of modify any of the layers from any layer, so to speak. That's an oversimplification, but so all our changes exist in that one layer. If we break, you can try an old image. It's easy to figure out what's going on, and then we have some pretty cool ways to debug if you run into problems. But generally, our customers don't have any problems. They're good.
Yeah, that's fascinating. Earlier on in my career, I dealt with a lot of backporting patches, right? And working with my devs to get them backported in, and then the scans are still failing, right? Because the scans are kind of dumb in what they're looking for. They're looking for that version change. Well, if you backport, the version doesn't necessarily change.
That's where the vex comes in. So we use these vex files to transfer this, and lots of scanners can take vex as input now. So that basically informs them about the package changes and what we changed. And that's also a transparency measure for you to be able to use that to for users of our platform to be able to understand our changes. I will also add that every fix we do, we subject it to standard open source practices. So we publish all of our fixes, all the code we change into a publicly available GitHub repo. It turns out it's really hard to do anything with these patches because the build stuff is really like we got a massive software factory, and to reproduce all these patches in a functional way from the source code isn't that easy. But we put it out there because we want people to see what we change. We want them to be able to review it if they want, and our customers want that. They want to know that we're transparent. We're not a black box. We're an automation system, and we do a lot of heavy lifting for customers to get those backports done. I'm sure that your experience with those backports is it takes a long time to build them. Like the
Yeah.
engineers don't like to do it, and it's fraught with risk. And I'll call it risk from getting engineers to like deliver is hard because it takes expertise to know how to backport things. Like we're really good at it, and our agents are really, 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 really good at it. I don't know what your memory is, but our agentic system can produce backports in like 10 minutes.
Wow.
It probably would have taken engineers to do the set I did. I know how long it takes. We did a bunch of them manually because we like to learn. Uh, the average backport takes 3 days, 4 days of an engineer's time, maybe more. Depends how
Jeez.
complicated it is. For really good research engineers, that's like it can be hours to days to weeks, depending upon complexity. Some of those patches we generated have a dozen, 2 dozen file changes, 5, 10 commits that we got to figure out like how it applies to that older version. And our system's very excellent at that. Back to your question though, I would say, yeah, we're getting integrated with scanners, so they naturally know about our packages because we put that .root.io, and we also have a feed that matches up the vulnerability fixes and the call it the effectivity statements. Like we fix this by doing the following into a feed, and scanner vendors can take those in and inform their databases. So that's one way you tackle it. And this is a very common way to integrate with scanner vendors so they know about this sort of thing. And then our VEX statements can be imported into scanners. Trivia is excellent at using this. Docker Scout's another one that's excellent using VEX so that you can inform your scanners about what we fixed. And of course, our scanner in our platform, which is Trivia, uses the VEX statements as well.
Yeah, it's fascinating. It's an interesting way of approaching this complex problem that so many people just want to run from it, right? They kind of want to
Yeah.
dodge it, and more of the infrastructure on the internet is running off of containers, and so people, in security are just like, they're kind of at a loss, right? Because they don't have something that they can say, hey, this isn't going to add an hour to your day or add a week to your sprint or whatever it might be. You can still deliver, your feature requests, your milestones and whatnot, as well as maintaining security in the product. That's, it's an interesting proposal for sure.
Yeah, and what you didn't see when I ran our tool, and this is exactly what our customers experience is, I didn't have to ask some engineer to change anything. All you need to do is plug us in. Like we literally have customers that, you know, do this for their 10, 20 base images, plug us into their CI/CD pipeline, get onto this SLA, like, kind of easy button. Because again, we're fixing all the new vulnerabilities that come too, and you're getting those as the service runs. And that's really the core of the service. The core of the service is making it easy for you to very quickly get your images to a really much better place, like near zero vulnerabilities or zero, and as I showed you. But then making it so that as vulnerabilities come, we're taking them on and fixing them as you go automatically. So SLA is the kind of the core of this service. They get through doing this on all their images in a week, less than a week. Then most of it's just them integrating it into their workflows and getting CI/CD set up. But we have customers that literally plug us into CI/CD in 4 hours, run all of the images, get through all of the testings, and be done in the same week. Yeah. No engineering resources required, and this will save them hundreds, if not thousands of hours a year.
Hmm. Yeah, that's definitely fascinating. That's really interesting to dive into. Well, John, unfortunately, we're at the top of our time here, and it's been a fantastic conversation. I really appreciate you coming on.
For fun. I loved it. I think I really appreciate that you do this and kind of put great information out there and excited that you are kind of caring for the community of security people out there. I think this is a wonderful service. So great to meet you and do this today and happy to help any way I can.
Yeah, absolutely. Well, I really appreciate that. Well, before I let you go, how about you tell my audience, where they can find you if they wanted to reach out and connect, and where they give their route.
Sure. So you can find us at www.root.io, and you can use the application just like I did with no hassle at app.root.io, app.root.io, ROOT, like the root or tree. And if folks want to reach out to me, you can just hit me up at john@root.io. I love connecting up on email. Just shoot me a note if you're interested or we want to talk.
Awesome. Well, thanks everyone. I really hope that you enjoyed this episode. More to come. Thanks, guys. Cool.